Since the beginning of modern man, boats have been taking on a variety of shapes and sizes and have gone through a plethora of transformations.
Their evolutions over time were not only catalyzed by new advances in materials, but boats have enabled immense advancements in human history via transportation, trade, maritime war, and even leisure travel.
In this video, we'll be talking about some key advancements in boats' general material makeup and be outlining the societal impacts with respect to these materials.
Today we're at the National Canal Museum in Easton, Pennsylvania, a blast to the past relevant to the local societal impacts of boat evolution.
The canal era in Pennsylvania began in 1797 when the Conewago Canal opened its locks and carried riverboats around Conewago Falls near the Susquehanna River. Pennsylvania built hundreds of miles of canals in the 19th century.
You are now looking at a blueprint of a typical raw material canal boat that would have been found right here in the Lehigh Canal.
One of the problems with these wooden canal boats was their limited lifespan. After elongated service, these boats were not resistant to a simple patch job and were eventually replaced by those with stronger steel builds.
And this example of the Lehigh Canal is just one of the steps on a smaller scale of evolutionary advancements of boats. It is no surprise that this simple alteration of the boat was so quickly outdated by the introduction of locomotives who had the ability to transport immense masses of bulk goods.
In this video, we'll be discussing the prehistoric boat's makeup and function. We'll be examining the impact of wood on boats, and next we'll dive into steel and iron. And finally, we'll take a look at today's aluminum-based boats.
It is important to note that prehistoric boats' material were based off of what was readily available depending on the region, for example papyrus in Egypt and totora reed for South America, and was a strong basis for later advancements in material alterations. One type of boat that was widely used by Homo sapiens included the raft. Common constituents included bamboo, logs, or reeds, which only required the most basic primitive cutting tools, and which propulsion was created by either paddles, ropes, and/or simply the human hand. While it may seem premature, these rafts advanced society by serving as fishing platforms, transporting various goods across bodies of water which hadn't been done in the past, and were even connected to form fishing villages. In general, rafts promoted a new sustenance for people who utilized them, and in some cases of the primitive log raft, more advanced designs allowed for the tapering of the bell. Some examples included the katamaran, which is still used along the southern coast of India, and the medieval Japanese muramachi. Reed boats were also a significant invention before the use of plankwood, which are made by assembling bundles of reeds to form the shape of a kayak. The impacts of these boats were quite uncertain, as many studies conducted by marine professionals sought to uncover whether these seemingly simplistic designs could withstand the elements of crossing entire spans of ocean. This specific UPenn study examined the lives of villagers who lived around the Lake Titicaca in AD 500. The community was able to transport over 130 tons of stone from distant sources to construct monumental tributes for their citizens. But how, especially with such primitive technology, was this achieved? In the study, Alexei Vranich discovered the ins and outs of the totora reed boat. He found effective totora reed weaving patterns to retain the most strength from the hull. After 2.5 months of construction, the 15-meter long boat, consisting of 1.8 million reeds, was completed as the team sailed into the waters and held their own expedition to see if they could transport massive rocks on overnight mission traversing the massive lake. The beauty of totora reeds is in the plant's makeup. The plant absorbs water up to a certain saturation level and then stabilizes. The experiment was a success, despite what the anthropologists deemed as a slow and arduous process. Anthropologists now knew that oceanic travel was possible, at least through South American regions, due to this discovery. The question still remained, though. Could we detect these sailings and influences on other global infrastructure? That is, could it have been possible for ancient Egyptians to base their pyramids off of the Aztecs?
Although the first boats were an incredible innovation and made travel and shipping across bodies of water much easier, the material choices were not ideal. Around 2500 BCE, ancient Egyptians began to build the first wooden boats by essentially carving out a canoe from a large log. By utilizing this new material, boats were able to withstand sailing across oceans and larger bodies of water. This advancement was crucial in the development of our society and trade between countries. Wood was a widely popular material due to its extensive availability, reasonable price, and material properties. Wood is relatively light for its strength, non-magnetic so it does not affect the compass when navigating, it's easy to shape into a canoe-like boat, and easy to repair. These material properties are very important when designing a boat that has to withstand traveling long distances. Although wood was a huge step in the right direction when it comes to materials for boats, it clearly had some negative properties. Wood absorbs a lot of moisture and starts to rot at 20% moisture. Because of this, wooden boats often started to develop holes and cracks fairly early into the life of the boat. This made regular maintenance of wooden boats necessary, causing a loss in money and time for people who utilized the boats. Many ideas were developed in order to try to combat these structural issues. Modern wooden boats utilize wooden ribs and planking. Crafted from the splits of trees, a boat's ribs are strong but also lightweight and use wood such as juniper, morenty, Douglas fir, and some plywood. The ribs of a boat are steamed in order to bend to the correct angle for the boat to withstand maximum strength. The planking is then attached to the ribs of the boat. Planking is the boards of wood that fasten in order to create a smooth outside hull of the boat. Fasteners were used in ancient days to create this planking, but now waterproof glue is primarily used. As you can see, wood is a great material for building smaller boats, but when larger ships are needed for carrying very large loads across huge bodies of water, other materials need to be utilized.
The next advancement following wood was steel and iron boats. It all began in the Wilkinson factory in Coalbrookdale in 1787 when the first iron boat was built as seen in the image. During the 19th century, ironclad on wooden frames, steel and other iron ships became popular. Mainly for war and carrying heavy cargo, the new advancements to boats truly came to fruition because of the Second Industrial Revolution. During this period, the Bessemer process was created to further the efficiency of manufacturing steel as allowing steel to be widely available. The main types of steel and iron used were low-carbon steels and cast iron. However, medium-carbon steel and wrought iron were used in certain cases. By switching from wood to steel or iron, major improvements were seen in the yield strength and fracture toughness. According to Appendix A, in the materials textbook, the yield strength of cast iron is from around 140 to 420 megapascals, and low-carbon steel is from 250 to 400 megapascals. However, wood is only 2 to 6 megapascals for a cross grain, or 30 to 70 megapascals along the grain. This difference is similar to the fracture toughness, and these values can be seen in the appendix as well. These significant increases created a stronger, safer, and more durable ship than one of wood. The higher strength allows for a much higher loading capability, while the improved fracture toughness helps keep the material from failing. Two other major elements for using iron and steel on ships were for the fire prevention aspect during war, which is where ironclad on wooden frames was seen, as well as the environmental impact of the material. According to research done by the MBMA, structural steel is recycled at a 98% rate. Not only does it save resources, but it also protects environments from losing trees for lumber that would have been used for wooden boats and structures. Now, it is important to also note that new advancements comes new problems and disadvantages of the material that will still need to be worked upon. One prime example is the Titanic. Being constructed of 1-inch thick mild steel plates and millions of wrought iron rivets, the cold temperatures and poor manufacturing techniques during this time led to a short lifespan and a tragic moment in history. The rivets and plates became brittle due to the elastic properties of the material, causing it to fail quickly.
The final advancement in material that we'll be discussing is from the use of iron and steel to the use of aluminum as a core material. Emerging in the 1960s, this improvement was a breakthrough in the boat industry, as aluminum's properties allowed for limits to be exceeded and for increased efficiency. Aluminum is manufactured from the ore bauxite, and the pre-cut aluminum parts, such as the hull and chine, are welded together. The major properties include a relatively lighter weight and great strength and durability for its weight. This meant that boats could then travel at speeds of 30 to 50 knots and be built in larger capacities of up to 1,500 passengers and 375 cars in fast ferries, while larger cargo ships could travel at 60 to 80 knots or more. and hold capacities of up to 3,000 metric tons. In terms of direct material comparison, in 1939, 14 tons of aluminum was able to successfully replace 40 tons of steel. According to an experimental study done by Scientific American, a lighter ship with lower density was able to hold more cargo and passengers due to the greater difference in densities with the water before its load was too heavy and would sink. While there were early misconceptions of aluminum being vulnerable to combustion and corrosion in the atmosphere, it proved to be quite a durable material that requires low maintenance, with reports of aluminum crafts lasting over 30 years with no signs of metal fatigue. In addition, aluminum is a non-magnetic material, which means that it will not interfere with the typical compass navigation used in marine travel. However, aluminum is not such a cheap material, making cost a factor to be put into consideration when building these advanced boats. But it makes up for the costs with its low maintenance and small amount of aluminum used in the production of the boats relative to the previously used steel. With so many significant benefits to switching to aluminum boats, the demand has been going up in recent years. UACJ, a leading aluminum producer, forecasted demands of 44,000 tons in 2015 and 56,000 tons in 2016 from LNG or liquefied natural gas shipbuilders.
Thanks for watching.
And thanks for joining us at the National Canal Museum in Easton, Pennsylvania.